All right, ladies and gentlemen, let's go ahead and get started here. Similar figures. So what we did there, we are continuing and doing here. Okay? So really, it is a very similar lesson, okay? If I can get my mouse to work correctly. So, solve each problem. So let's see that math put away. All right, Kevin? All right, let's see those other ones put away so we can be here with this. Have your notes from the last section out. Now, we know the cross multiply and divide, so we get 90 equals 9b divided by 9 divided by 9. So it's 10, right? You remember how to do that, correct? That is what all of today's lesson is going to be based on, okay? Similar corresponding sides, corresponding angles. Now, figures have the same shape, but not necessarily the same size. Both are squares, but they're not necessarily the same size. They're similar. But here is the one thing that's there. So if this side is 5, and this side is 20 for the square, all sides for this square are going to be 5, all are going to be 20. Do you see how every side changes by a multiple of 4? Yeah. So they're in a ratio. The sides are in a ratio, okay? Corresponding sides of two figures are in the same relative position. Okay? Right angle. Right. What is corresponding to this side? Is it the vertical angle, or the vertical side, the horizontal side, or the diagonal side? Which one is corresponding to the x? Gavin? Gavin says this one is corresponding to the x. Do you see how they're the same side of the same figure? Okay, that's what it means by corresponding sides. They are in the same relative position. Now, sometimes we'll take and we'll turn these things, and then you got to figure it out. But what about this one? If I put a y here, which side would be the y side on the other triangle, the smaller one?
I don't know what it's called, but it's...
Would it be the vertical? The hypotenuse. Okay, that's a way to name it. Very good. The hypotenuse, the diagonal side, right? And then that leaves these two sides to be corresponding as well, right? All right, Tori, I'm seeing the eyebrows knitted. What's that mean? You got it? Okay. All right, very good. That's just what I wanted to make sure of. All right. And corresponding angles are in the same relative positions. So, if this was the angle I'm talking about, is that the corresponding angle? Yeah. All right. So if you line them up the same way, you're talking about the same side of the same angle. They're in the same position. All right. Two figures are similar if the lengths of the corresponding sides are proportional. This part that I underlined, that is where we're going to use our ratios. Jacob?
If the angles are the same from the sides, like don't that be
That'll be what they talk about. If our angles are the same, the sides will be the same. If the angles are not the same, the sides cannot be proportional. Okay? Because the sides can be proportionals, but the angles will always be the same no matter what. So if this angle is 35 and these are similar, this angle will be 35. Okay? All right, let's move on. So they show you a picture of it. Do you see how those angles are the same? Do you see how we have to kind of turn that and set it on its side? Do you see how they did that? Why those that I circled in red are corresponding? Yeah. Yep. All right. And then, which side is corresponding with this side that is 24? You can tell me, is it the 36 side, the 60 side, or the 48 side? All right, so I have one person saying the 36 side.
48.
I have a few people saying the 48.
Yeah.
Oh, did you change it? Yeah, I see her doing that. She's driving the car, and that's what I do. I literally do that in my head. you'll see my hand turn. Do you see how we take that and just kind of lay it down where that's the bottom side? Okay? So, it is the 48 side. You don't see it, Tori?
Flip it on its side, Corey.
Take this one, turn it to its side.
That's the same exact problem as the big one.
Yeah.
Oh, the light bulb just clicked. All right, we found a short circuit. All right, you feel better about it? Okay. Now, notice what they do over here. Don't those look like ratios?
Yeah.
Yeah. So, if I said 24 over 40, oh, it could be ratios. Okay. So let's look at this. Which rectangles are similar? So we've got to compare their sides. So how do we do that? We're going to write a proportion. Taylor,
Just,
you knew the answer, you think?
I don't think so. I want to see to the first one first.
Okay. Which one's Christine?
It's the one 10 and 5 and 4, so those are the same ones.
So triangle J and triangle K. Now, they saw that,
Oh, I see.
but here's how you can check that.
You just don't want
Because of the numbers, one's just.
Oh, do you see how those sides are corresponding? Because that's both the tall side. Oh, so 10 to 5, that's divided by 2 or multiplied by 2, whichever way we go. This side, you see how that's divided by 2 or multiplied by 2 as well? Okay, so since you can do that to both sides, they are proportional. All right, and if we look here, well, 5 doesn't go into 2. Well, that's 2.5. It just doesn't work. But here's what you can actually set up. I could do 10 over 4. Oh, not, yeah. All right. And that's equal to 5 over 2. Do you see how I have my long side and long side equal to each other? And I have my short side and short side equal to each other? And when I cross multiply 20 and 20, do you see how that works out? So we can set up a ratio with these, right, Michaela? Okay. And when I do that over here, if I have my 5 over my 2, and I have my 12 over my 5, whoops, equals, because this is the long side and this is the short side. This is the long side and that's the short side. Do you see what I'm doing with the long side and short side? Does that make sense? 25, 24. Oh, they don't measure out, do they? Okay. So you can set up proportions, right? Do you see that, Haley? Because they're not going to all be as easy as that to see. Which, good job seeing that, but they're not all going to be that easy. Okay? Okay. Since the three figures are all rectangles, all the angles are right angles. So the corresponding angles are congruent. So the angles are congruent, but we don't know about the sides. Let's compare the ratios of the sides. Okay. 10 over 5, 4 over 2. Okay. Okay. So we do our cross multiplication. These equal, those don't. Hey, we've got the ones that match, and we can throw the third one in there. So let's do this one. Who can help me set up the ratio to compare these two? Who can help me set up the ratio? Taylor, you're willing? All right.
I think it'd be 8 over 4 and then equals 6 over 3.
Equals 6 over 3. Do you guys agree with her? Because she's doing the length side, They're across from each other, right? She's doing the width side, and they're across from each other. So did she set it up pretty good? All right. So then as we cross multiply, we get 24. We get 24. Does that work pretty good? All right, Natalie, can you help me set up for B and C? Can you help me set up the ratio?
6 over 3 equals 5 over 2.
5 over 2. Okay, so length side. Hey, that's good. Width side. Hey, that's good. 12, 15, do they equal? No. So it looks like we're doing A and B is equaling, right? But what's the last comparison we could make on here, just to double check? A and C. So if we do A and C, Lucas,
Right.
okay? If I'm comparing those two, what would the numbers look like? What would the fractions look like? Oh, out of the hood when you're in my classroom.
8/4.
Okay?
And 5/2.
5/2. Did you do it right, Trenton?
Yeah.
Okay? Because we have length side, yeah. Width side, yeah. 8 times 2 is 16. 4 times 5 is 20. So which ones are the proportional ones, Drew? Which two triangles are proportional? A and B. They're proportional or they are similar is the word they use. I used the wrong word. Okay? Very good, very good. They're going to show us all their math just like we showed them. Come on, keep up thing. There we go. 24. All right. 16. So we know A and B are similar. Okay? Now we put it into new situations, okay? Draw pictures. You don't have to be artists, but draw pictures. A picture is 10 inches tall and 14 inches wide. So 10 inches by 14 inches. Okay? It is to be scaled to 1.5 inches tall and displayed on a web page. So they're taking it, you know how you take the corner and you go and you make it smaller? That's what they're doing for the web page. So they're making it smaller. What measure do they give us for the smaller
1.5 inches.
tall? So it goes here? It does. Do we know how wide?
No.
No. A. Oh, you want to put A? A. How wide is it? So how do we set? Go ahead, Taylor.
10/14, 1.5 over A.
Did she set that up right, Christine? Yeah. Okay. How tall? How tall? Tall and taller across from each other, right? Connor? How wide? How wide? Are across from each other. So she did pretty good. So now what do we do, Connor?
Do 10 times A, which is 10, and do 14 times 1.5.
Which is
21.
21.
Okay. Very good. Now what do we do, sir?
21 divided by 2.
Okay. I'll write it up here since you won't help me. All right. 20. So 2.1.
Yep.
2.1 inches, right? That's how we find a proportional thing. How you feeling about it, Hayden? Yes, no, purple? In the middle, okay. So, draw the pictures. The pictures will help. A lot of kids try to just see them up here. Draw the pictures, okay? So, Taylor, well done there. Okay, let's make sure that we see exactly what they set up, because it's exactly like Taylor's, but their handwriting is better than mine. Okay? Good. All right. Very good. So now we have a painting that is 40 inches by 56 inches. And they don't even have to be to scale. 40 inches long and 56 inches wide. 6. So this is long and this is wide. Okay? It's to be scaled down to poster size. So this is when they did big old oil paintings. Okay? So as we go here, Summer, it is to be scaled down to 10 inches long to be displayed on a poster. So which side of that smaller version gets the 10?
The bottom.
The bottom gets the 10? Okay? So 10 inches long,
Oh, never mind.
the side. And I wrote them here because that makes a big difference to me, okay? 10 inches. Don't be afraid to label and do it. I hope to see pictures, okay? So, what do we know about the width then, Trenton?
Would be
Do we know the width? So if we don't know the width, what can we do? We could do the x here. Okay? How could we set this up then here?
40 over 56 and 10 over x.
40 over 56. So we did long over tall and 10 over x. We did long over wide. We did long over wide. Both fit, right? She did a good job. All right, from here, where do we go, crew?
you would cross multiply.
560. So that's 1 and then 160. 14. So this side is 14. All right. Did you see the shortcut, Gavin? What is the shortcut, Gavin? Do you see how they divided by 4? Divided by 4. Well, that's 14. Because that's what we ended up doing, divided by 40, right? So, do you see how that was just reducing fractions? If you like to cross multiply and divide better, that's fine. That's probably good. But if you can start to see that correlation, good for you. How you doing, Tori? All right, good. All right, online, you're up next. Now, let's hold on. They did something different. They did 56 over W. Oh. So they compared the wide side to the wide side and the long side to the long side, right? But they still did both the small triangles on bottom and both the big triangles on top. Okay? So that's kind of like writing it one way or another. So a t-shirt design includes an isosceles triangle with side lengths of 4.5, 4.5, and 6. Isosceles. Two sides are the same, one side's different. 4.5, 4.5, and that one's 6. Okay? An advertisement shows an enlarged version of the triangle with two sides that are 3 feet long each. Three feet, and those are measured in inches. There's an extra thing that makes this problem hard. What is it? Yes, Natalie?
You have to convert the feet into inches.
Oh, 3 feet is the same as 36 inches, right? 36 inches, right? Okay. Okay, and then X for the bottom, right? So 3 feet, I would just rename it 36 inches because those are the same thing, right, Lucas? All right, Lucas, do you think you could set me up an equation to help me figure out what the bottom is? Okay, what is it, sir?
It would be 36 inches over 36 inches. 36 and 36. 41.
So we've got those two sides. Do we need to find one of those two sides? So we should probably incorporate that X in there.
Over X.
Over X, okay?
And then 44.5 inches over 6.36.
All right. So you got the bottom of the triangle, the bottom of the triangle. You got the side and the side. It could be either this side and that side, or that side, since those are the same, the isosceles there. Did he set it up well, Connor? Yep. All right. From there, we get 4.5 equals 6. That's 36 and 18. So that's 216. All right. And then what do we do, Tori? Divide. All right. Divide by what?
4.5.
All right. And 216 divided by 4.5?
0.005.
I think you did it backwards.
Yeah, I did.
All right. What's that?
48.
48. X equals 48. All right. So hopefully, in Trenton, if you see that, did you realize? Ooh,
Yeah, I did.
that wouldn't be there. But yeah, that happens. We put them in backwards sometimes. Oh, so 48 inches. Okay. That is bigger than that, right? 6 is bigger than 4.5. So would it make sense that 48 should be bigger than 36? Yeah. So you can kind of see that it's right. Are you guys feeling pretty good about setting them up? Would you like the last 20 minutes to work where I can come in and help you? All right. So you guys go ahead and start working. I'm going to check through and make sure